So I look at the metrics. I've looked at the graph. I've made a qualitative decision that I don't think I need to do anything with this model, but I do have to actually check. And there are industry rules of thumb about kind of what's good enough. This is a commercial building. That's the first thing to recognize. So the R squared, this is answering the question, what percent of energy consumption at the site is explained by the model? So 82% of energy consumption at the site is explained by the model. Since this is a model with almost nothing in it except for weather, that's pretty good. For a commercial building, 0.82 is pretty good. I also go and check the last time I ran it a month ago. Was it close to 82? It was close to 82. Then I check the coefficient of variance of the root mean squared error. We're just going to call it the CVRMSE. In the industry, you typically want this number to be lower than 0.25 for hourly models. This number, if you follow M&V News, gets argued about. It's not actually settled. But 0.197 is lower than 0.25, and it has not really fluctuated from the previous month. The baseline normalized energy consumption. This is what we think the first year savings, or the first year consumption is for this site. I don't really expect this number to fluctuate month to month, and it didn't. These are big numbers, so you really shouldn't think about significant figures from when you were young, and you don't need to look at the little numbers near the trail end. It's false precision to have decimal points on those things anyway. Then there's the normalized annual energy savings, so like the first year estimate of how much savings this site has. And this has had a bit of a fluctuation from May to June. But what happens at a school from May to June? School gets out. So I'm not surprised to see a fluctuation there at all. And the rule of thumb in the industry is you only need to add a non-routine event or respecify the model if the savings fluctuate by more than 10%. I have run this model both ways, and I know that they don't, even though I didn't show that to you. But this is not the best number I've ever seen. It could be more stable. I probably wouldn't want to call this model settled yet. I'd want some more data, probably another summer. But it's not bad. It's got 10% savings, had 11% last month. That's still nice and high for an interval data model where you want it to be greater than 3%. Fractional savings uncertainty. This is kind of the plus or error bars on the side of your metric. So it's like savings plus or minus 9% here. In site level modeling, you typically want that to be below 50%. That number is not contentious. It is quite settled. Avoided energy consumption to date. This is the value that was being shown on that CUSUM graph. And what I am looking for on a month-to-month change for this is simply an increase. I don't want savings to go down, indicating that suddenly they're using more energy consumption. And based on how much time has passed since the change was implemented, I also want it to be proportional to the normalized savings estimate. So when I hit 12 months after change, I want to see my avoided energy consumption being really close to equaling my normalized energy consumption, unless it was a bizarre year, but that's a different story. And then this is the savings uncertainty for that avoided number. I don't actually use that as a metric, and then I didn't calculate peak savings for this, but if I had, they would be there.